if there's no questions, I'm just going to start throwing math at you verbally. So, just to kind of review a little bit of what we did last time. How do I get a vertical asymptote? So for example, if I have this equation, where would the vertical asymptotes come from? I got to factor to the bottom because vertical asymptotes are related to the domain, right? It's literally putting a wall at the values you're not allowed to use. So if I factor the bottom, what do I get?
Plus 3 minus 3.
Yeah. Okay, I can already tell I don't really like this one as much. X plus 3, x minus 3. The top would be x plus 2, x minus 2, but that has nothing to do with the vertical asymptote. What would the vertical asymptotes be then? 3 and x equals negative 3. I like it. Okay. So, and then you would put walls there. What would the top tell me? I factor the top. What would that lead to me knowing? X-intercepts. What would the horizontal asymptote be for this problem? It's a very excited H. I'm not sure what happened to that H. Yeah, what situation am I in? The degrees are the same, so it's just the ratio of the leading coefficients, so that would be 1. So we did a few examples yesterday about that, so now I want to kind of fill in some holes. We haven't looked at every situation for horizontal asymptote yet. We also haven't seen everything that could happen related to vertical asymptotes. Right? So please do that for us, Jeff. Okay. So what if I have this function? Something special about this poor little dude. Okay. Can you guys take a moment and just factor the top and bottom? Because it's pretty much, if I give you a rational expression, it's the first thing you're going to want to do. Just factor it. And only factor it. The top and the bottom. Don't do anything else yet. It's really weird. Anyway, so what do you got on the top? What do you got on the bottom? X plus 3. X plus 2. So if you only look at that without thinking about anything, where would you think there should be vertical asymptotes? Negative 3, negative 2. And I would say, okay, that makes sense, but there's one of those is not true. So the whole idea is, just to remind you guys, so we did this before, and it's easy to forget why. You all agree negative 2, there's an issue. You just can't get away from it. There's an issue at negative 2. Normally, if I get really close to x equal negative 2, the bottom becomes really small, so the whole thing becomes really big. You guys with me? That's exactly how we approached figuring out why it goes to infinity and negative infinity. Because if I get really close to negative 2, that x plus 2 piece is going to get stupid small. So then the whole thing would normally get really big. But in this case, doesn't the top have a piece that's getting equally small? These two things, the effects cancel out. It doesn't go to infinity because when the bottom's getting stupid small, so is the top. In fact, mathematically, what should those two things do? Cancel. Now, the minute I cancel it, and I get x minus 2 over x plus 3, that does not mean suddenly that 2 is okay to use. Because what's the only time I am allowed to do this cancellation? It's a very strange question. There's actually a specific time I'm not allowed to cancel those. If x is negative 2. And just a quick side note. What is 0 divided by anything? 0. And what is anything divided by 0? Undefined or infinite, right? We know that better now. 1 over x goes to infinity if you let x go to 0. Yes? That's the whole idea of vertical asymptotes. So this is kind of like infinity. So what is 0 divided by 0? It is both 0 and infinity. What? Okay. So I cannot plug -2 in. It's not allowed to be used. But do you agree there's no vertical asymptote at -2? Where's the only vertical asymptote for this thing? -3. So what the shit's going on at -2? I don't know. Well, let's find out. Okay, let's find out. Oh, am I smart enough to do this? Let's all find out together. Oh, no, you're not, because you forgot where it is. Yeah, I did. I forgot where my Safari is. Is there no Apple?
The compass.
The compass?
Yeah.
Next to messages.
Next to messages. Oh, this thing?
Yeah.
Oh, neato. Oh, there's Desmos. Look at me go. Sorry. So, help me out. What was the function I just gave you guys? Oh, will it let me type? Oh, that's going to be a problem. Oh, there it is down here, Jeff. Oh, shit and a half. Oh, okay. Let's see. Y equals. There we go. What was the function? I'm sorry. Parentheses. There it is. What was the top again? Sorry.
X squared minus 4.
X squared minus 4. Thank you. Oh, shit and a half. Where's my x? There it is, Jeff. X squared minus 4. Oh, this is excruciating. Too bad. Divided by. The bottom was who to what? X squared minus 9? Is that right?
X squared plus
5x
plus
minus.
Oh, that's right. I'm thinking about the last one. X squared plus 5x. You could do it, Jeff. You could do it. You're almost there, man. You're almost there. Plus 5x plus 6, right? Damn it. Oh, man. So close. 5x plus 6. Okay. So, I don't know if I'm going to be able to do this. That's a good point, Jeff. Shoot. So at x equal to -2, this is not going to be able to show it to me, is it? I'll have to do it on my calculator. That's okay. Let me show you what happens. Desmos is really cool except for this one thing. Go away. Stop. It's thinking. There we go. Okay. So if I put in here the function x squared, what was it, minus 4? Jeff. Yeah, good morning support. X squared minus 4 divided by x squared plus 5x plus 6. Okay, now, if I zoom 6, if I graph this thing, everything looks fine. I see a vertical asymptote at -3, right? I don't see a vertical asymptote at -2, and I shouldn't. But what's happening at -2 then? Well, if I ask it, so let me show you. If I do calc, if I calculate the value at, let's say, 0, it'll tell me the output at 0 is -2/3. So if I try to do the same thing, calculate the value at -2, let's see what it says. What does it say? Void, right? It's the dark, it's the empty, your empty soul. No, so it's telling me there's an open circle there. So if a location of a vertical asymptote actually ends up canceling, you still aren't allowed to use that value. But instead of a wall, there's just an open circle. And you can see that right here. This is how it tells me there's an open circle. Okay. I like it. It's just cheap, Jeff. So that's one little weird thing that could happen. If one of your factors cancels, instead of a vertical asymptote, it's an open circle. So literally, on your paper, when you have to graph this thing, you just draw an open circle there. Instead of a wall. No big deal. Okay. Let me see. Okay. Now here's a really good thing to ask then. Really good question to ask would be, well, where the shit is this stupid open circle, Jeff? Now you got to figure out how to go back. You'll do it. You'll do it. You did it. Where is the open circle? Yes, you with me? I know it's at -2 for x. I know x is -2, but where the hell is the open circle? Does anyone have a clue how to figure out where that open circle is going to be? What is this function everywhere except -2? What is it equal to? This, yes? I need you to understand. Does everyone agree that mathematically the function I gave us reduces to this, yes? The only place it doesn't work is -2. But if I plug a -2 in here, I'll get -4 over 1. So the open circle is at -2, -4. And if I come back to multimedia, it's going to drive me insane. You could do it. You could do it. Or was it here? Okay. That's for later. Shoot. Sorry. Too many things happening. Safari. You guys help me with that. Right here. -2, -4. That's where the open circle is going to be. Why does it not have an open circle there? Because it's less than a pixel big. You guys understand? So it's not going to have this big ass open. It's an open circle. Okay, maybe. I'm really curious. Give me a second. Well, that's all we ever do, Jeff. Jeff. It's here. Okay, sorry. If I put in here x equals Jeff. X equals. Does it understand this is -2? Let's see. Yes. And then I ask it to find the intersection. Will it do it? Oh, it actually says it's -2, -4. That's disturbing. All right, Desmos, you've failed. Go away. Okay. All right, is everybody sort of with me? If the bottom has factors that go to 0, there's an obvious problem there. Most of the time, it's going to be a freaking wall. If the problem cancels, it ends up being an open circle. Because it doesn't go to infinity then. Yes?
You can check that by plugging -2 out the original function, right?
Well, if you try to plug it in the original, you get 0 divided by 0, which we said was somehow both 0 and infinity. So it really isn't division by 0 that freaks things out. It's 0 divided by 0 that destroys the universe. Yeah. So don't try to do that too much, please. Okay, we stop for a minute. So this is a little side note. It's not going to happen often. I think there might be 1 or 2 places in the homework that this comes up. Maybe not at all. I can't remember. All right, the other thing that's more huge. What did I just do? Go, whatever you are. Stop it. I don't want that one. Oh, you're all having so many good times with me. Okay, I just want another page. Thank you. Okay. Sorry. Is what happens. So tell me what we know 2 things about horizontal asymptotes. Can somebody tell me what's the situation that leads to y equals 0 for a horizontal asymptote? If what? If the top power is less than the bottom power. Blah, 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 blah. That would lead to that. So x to the 4th over x to the 5th. If the top degree is smaller than the bottom degree, it's going to go to 0. Which makes sense because the bottom dominates. The bottom gets stupid big and the top can't keep up. It goes to 0. It gets small, small, small. When is it going to be like, can somebody come up with an exact thing that has y equals 3 as a horizontal asymptote?
3x squared over x squared.
3x squared plus blah, blah, blah over x squared minus blah, blah, blah. Because if I have the same degree, top and bottom, it's a ratio of the coefficients. I love it. Okay, so those are the 2 situations we're talking about. What's the only situation we haven't talked about yet? If the top degree is bigger. We haven't talked about that. Now, if the top gets really big and the bottom can't keep up, what do you think that means? So the top is going 10, 100, 1,000, and the bottom's going 2, 3, 4. Right? The whole thing is getting really crazy big. It goes to infinity. But here's the cool thing. So this is the idea of slant asymptotes. Some books call this oblique asymptotes if they want to be really weird. Let me show you, before I do, the technical idea behind this. In fact, yeah, this is perfect. All right, so this is what I had this set up for. Do you all agree that this looks linear? I don't know if you guys can see, but do you see how I'm really zoomed out?
Yeah.
I don't know if you noticed, but isn't the y-axis somehow also part of the graph? Yeah. So real quick, all right, let me see if you guys are cool with this. That kind of almost looks like it goes through the origin, correct? You guys see that? But it doesn't, to be honest. It's really close. So if I wanted to figure out what it seems, I really want you guys with me. That's a line. It looks like a straight line. I don't blame you, because I agree. But I'm tricking you. It isn't. Ha, 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 ha. But if I'm like, what is the equation of this line? Let me pick a point on the line. Can you guys all see that point? That's very tiny. You can look there. You can look there. So that point says 4580, 4577.9. So like 4578. The x is 4580, and the y is 4578. So what does it seem that's true about x and y? How does y relate to x? 4580, 4578. No, not the ratio. How different are they? 4580, 4578. You can do it. I've rounded it. So 4580, 4578. 2 off, right? So y equals x minus 2. Do you agree? Not perfect because I rounded it, but isn't it close to y equals x minus 2? If I go down here, it's still roughly x minus 2, but it's a little further off. Okay, so this line seems to be y equals x minus 2. And how did I see that? I just picked a point and saw the relationship, because that's all an equation is a relationship between the x part and the y part. That's all a linear equation is, or any equation. So if I zoom in though, then we start to see some weird shit. Okay, that's weird. So in the middle, it does freaky stuff. In fact, it freaking has a vertical asymptote here somewhere, right? And that's why it looks like the y-axis is in red also, yes? So, when x is small, it does freaky shit. Yes. When x gets really freaking big, it becomes like y equals x minus 2. Do you all agree? So let's look at this function. There's this. Oh, there's that. Let me write this function down for myself. So it's x squared minus 5x. Divided by x minus 3. If you factored it, would anything cancel? Where's the vertical asymptote? X equals 3. So that's exactly what we saw on the graph, correct? We saw a vertical asymptote around 3. Okay, that makes sense. The bottom degree is smaller than the top. Can you divide this thing? Yes, you can, of course. Yeah. Can you long divide it? Or even better? Synthetic. Why does synthetic division work on this one? Because the bottom is linear slope 1. Yes? Take a minute and synthetically divide this. Don't forget, is the top missing a term? Yes, it is. It's missing the constant term. So put a 0 on the right place. So I'll wait. Go ahead and synthetically divide that. Let me remind you, from the picture, it looked like y equals x minus 2 is what it becomes. Let's see if you see something interesting happen. So that's what your synthetic division setup should look like. catch up to you. 1, 3, -2, -6, -6. How's that? So, what's the results then? X minus 2 minus 6 over x minus 3. Now, help me out. When x gets really, really big, that's the horizontal asymptote we're talking about now, right? When x gets really big, what does this do? When x gets really stupid big, what's 6 divided by stupid big? Stupid small. So what does this go to in the end? 0. And I'm left with exactly what the shit we saw. When x was small, this function did whatever it wanted to. When x gets big, it must approach x minus 2. That's what we just figured out. When x gets really big, this function is effectively x minus 2. So, it will go to infinity because the top degree is bigger than the bottom, but it goes to infinity in a very prescribed manner. It follows x minus 2. What does a horizontal asymptote mean? Eventually my function must get close to it. So in this case, I have a slant asymptote. There will be a dotted line at y equals x minus 2, and eventually my function must come up against it. Okay, maybe. So let's try a fresh problem. Plus, make a new page. Okay. What did you do? Okay. Very quickly, funny story, by the way, because your teacher sucks with technology, apparently. I thought it was good. I was teaching class yesterday, and I hit a button somewhere, and everything I had written that day replayed. I was just standing there, and it was like as if I was writing. And I was like, oh, how did I do that? I want to know how I did that so I could do it again on purpose sometime. But oh, so we're going through time, everybody. All right, so here, let's try this one. X squared plus 5x minus 1 over x plus 2. Sure. Let me first say this. Well, the top factor. No. So what is the vertical asymptote? X equal -2, yes? Okay. So then I normally find the ha. There is no real ha. There's a slant asymptote. There's a sa. Sounds like a rejected note. Do, re, mi, fa, sol, la. It's like, what about sa? Can you guys take a minute and figure out what the slant asymptote is? I'll wait. Right, I'm going to do this synthetic division because I can. Not every problem you will be able to, but since the bottom here is linear, coefficient 1, synthetic works. Bring the 1 down, multiply, add, multiply, add. I think I did that right. So what is my slant asymptote? X plus 3, because the remainder term will go to 0 if I let x get big. And the whole idea of horizontal asymptotes is, what the hell happens if x gets really big, positive or negative? So yes, there's a remainder term. There is. There it is. There's the remainder term. Whoop-de-doo. It goes to 0 if I let x get big. So this is my slant asymptote. So what the shit does that mean? Okay, let's find out. So I've got, where'd it go? There it is. There's a vertical asymptote at -2, yes? And then there is a slant asymptote x plus 3. Can anyone tell me anything about x plus 3? Tell me anything about it.
Starts at 3 and
What do you mean starts at 3? What do you mean? Be more specific.
y equals 3.
So 0, 3.
Yeah, 0, 3, yes.
Okay. And it goes
Over and over.
over one, up one, and it goes down one, back one even. So then this is now a wall also. So it's just a horizontal that's been, turned a little bit. That's all. So now watch. Okay. I like my undo button. Do I still have an undo button? I do. Sweet. So what could happen? I need you to see this. It could either be here in that region, or it could be here in that region. Yes, that first strip. And on the other side, it could either be here or it could be here. Do you see how it's the same idea? It's just my wall just kind of like bent a little bit. But it's the same stupid idea. It's got to run up against it somehow. Obviously, that's not the answer because that's not a freaking function. It doesn't pass a vertical line test. Those are just the options. How do I tell what's what? Plug in a freaking number. Is something happening? Is stuff happening? Yes. Good. Continue to go away. Continue to go away. Continue to go away. Continue. Keep going away. Can you go away? Yeah, thank you. Okay. That's the only two colors I have? Whatever. I'll be fine. Ah, look at me. Let's do purple. What the hell? All right. Can somebody give me an idea of a number to plug in to see what the hell's going on? How about the y-intercept? How do you get the y-intercept? By the way, that point, look at this. You ready? Look what I was about to do. That point right there? No. So this point right here, is that an actual point? This point right here. Is that a point on the graph? No, that's just for my slants, right? Okay. So what do I get when I plug a 0 in? What's the y-intercept? -1/2. I love it. So therefore, I must be here, yes? There must be an x-intercept here. And to get the x-intercept, I'd have to do what? Does anyone see? How would I get the x-intercepts? I'd have to use, you could do it. Can you factor the top? So what do you have to use to figure out where it's 0? That's right, okay. What other number can I plug in now? Yeah, now I got to know what the hell. So I need to know what's going on here. I need to know what's going on here. So now we know what's going on here. It's got to slam up against this wall. It's got to slam up against that wall. I need to know what's going on. It can either be here or there. So if I plug in -3, where do I have room? What do you get when you plug a -3 in? Let's see. 9 minus 15 is -6 minus 1 is -7. Over -1 is 7. Did that quickly, but I think that's right. So I get 7, which is way the shit up here. So I know it's going to do this. Wee-haw. Wee-haw. That's really bad, but oh well. I know I'm in there. Are you with me? So once you set your walls up, I don't care if this wall does this or this wall does that. I automatically know kind of like what the shape could be. And then if I just plug a couple points in, I'm like, oh, cool, it's this and it's that. It could have been here. But it wasn't, because my y-intercept was way down there. Yes? Okay. Go away. Go away. Keep going away. Good. Okay. Let me stop for a minute. So slant asymptotes are weird. Why was this slant asymptote linear? I love this question. Why was this slant asymptote linear?
It's only the top's only 1 degree higher.
The top is only 1 degree higher. So what's an example, Jeff? What the shit happens if I make the top, let's see if you can do this. Can you? I don't think you can, Jeff, but let's find out. Ooh, I can. I'm going to put a 4 there. So now the degrees are going to be off by 2, yes? So my slant asymptote should look like x squared. It should look parabolic. Sure enough, if I zoom out, doesn't that look like a parabola? Very skinny parabola, yes? Because when x gets really big, I'm going to have x squared plus shit when I long divide. Why am I going to have to long divide this? Because the bottom is not linear. Okay. And when I zoom in, though, when x is small, look at the freaky shit it does. Doesn't it do some freaky shit? I don't know if you guys are with me. Doesn't it do some freaky shit? Yes? And down here, it's all over the damn place when x is small. But if I zoom out and make x big, it just looks like a very skinny parabola. That's all it looks like, yeah. Just like before, when I zoomed out, it just looked like a line. And then I zoomed in and it did weird shit. Yes? Okay, maybe. That's slant asymptotes. I'm pretty sure the ones I gave you have a linear slant asymptote. Could be wrong. I might have given you one with a parabolic, but we'll see. Okay. So, if there's no questions on that, those are the two last things that were left over from section 5.6. How are we feeling about that? Yes?
If the asymptote was like a parabola, could there be like an inner parabola like in it? Like,
Well, it has to be a function. So it can't not pass the vertical line test. It has to pass the vertical line test. Does that make sense?
Yeah, but if it was like super skinny.
Well, this one sort of does a little bit of what, see how it has like it's,
Like, would you check that?
look at that, see how that, yeah. But that one goes, and let me see. Let me ask you guys, where's the vertical asymptotes for this thing? The bottom was x plus 2, x plus 3. So there's a vertical asymptote at negative 2. I'm sorry, this was the, oh yeah, this will still work. This will work even better now. There's a vertical asymptote at negative 2 and a vertical asymptote at negative 3, yes?
Mm-hmm.
So that's why you see some weird stuff happening here. What is this? Let me show you. Holy crap, where am I? Trying to keep track of that line. There we go. Negative 2. There's a vertical asymptote at negative 2, and there's a vertical asymptote at negative 3. This is a little... Do you see how that red line is approaching that blue line?
Yeah.
I remember the blue line is left over from before. If I put... screw it, I'm not going to play this. It's enough, yeah. So in the middle, when x is small, it could do all kinds of weird shit. But at the ends, this is almost like end behavior now. At the ends, it's got to be parabolic. Yeah, okay. So open circle instead of a wall, instead of a vertical asymptote. That's one thing that can happen. Slant asymptotes can happen. They're a little more like side notes for the most part, but they can happen. So there shouldn't be a ton of these in your homework. There should be a couple. Just to kind of remind you guys, oh yeah, these weird things can happen. Okay. All right, maybe. Okay. Bit of good news, 5.7. Let's make that extra credit. For the most part, it's a repeat of stuff we've done before. There's a couple of kind of new things in there, but not very exciting. So we can throw it out. You can do it for extra credit. So what does that mean? If you do it and you get enough of it right, it'll add some points to your homework average. So you could end up with above 100 homework average if you do all the homework and you do the extra credit. Or if you didn't do some homework, you could do the extra credit. It'll take the place of that. You know, to a certain degree. Yeah. Okay, maybe.
What is that, graphing inverses?
This finding inverses of squares, but we already found inverses, so it's kind of like mostly a repeat. There's a couple kind of new things, but not really. Yeah, so I'm okay with throwing it out so we can get back on track. Because we need desperately to get into chapter 6. You know, like, we're fine. We don't need to, Jeff. Too bad for you. We do. Come back to blue. Yeah, you're good. Okay. So chapter 6. Have you guys ever heard this silly thing? Let me know if you've heard this. Would you rather I give you $5 million right now? This is obviously hypothetical because I'm a teacher. Would you rather somebody give you $5 million right now? Or would you rather somebody give you 1 penny now, and tomorrow they give you double that, and the next day they give you double that? So on the third day you get 4 pennies. 4 pennies, guys. Come on. So would you rather get $5 million now, or for the next 30 days, I'll give you 1 penny. The next day I'll give you twice that. The next day I'll give you twice that. So the next day you're up to 8 pennies, guys. Come on. Which one do you want? Which one do you want? Come on. What do you think? Has anybody ever heard this before?
I feel like it.
If you've heard of it before, keep it to yourself. You might remember the answer. Obviously the answer is pennies, because you know it's a trick. But if you had never heard it before and somebody uses it, you go, I don't want pennies, give me freaking 5 million. Now, either way, you got more money than you do now, so what the shit. But how much more money could you get if you chose the pennies? So let me ask you, day one, I get 1 penny, yes? Watch out. All right, that almost doubles my bank account. Day 2, I get how many pennies? 2. Because that's 1 times 2, yes? Day 3, I get how many pennies? 4. Because that's 2 times 2. It's 2 squared. Day 4, 8. Because that's 2 times 2 squared. That's 2 cubed. Do you see a pattern happening? On day 2, it's 2 to the first. On day 3, it's 2 squared. On day 4, it's 2 cubed. So what's day 30 going to be? 2 to the 29th, yes? Does anyone have the calculator with them? Let's see if a calculator can do this. 2 to the 29th power. I'm pretty sure it won't overflow. Yeah, good. Okay. You guys get something? Now that's that many pennies, yes? That is comma, 536 million, almost 537 million pennies, yes? How many dollars is that? 5.36 million, yes? We're 5.37 million. You guys with me? But then you say, well, that's about the same. But no, every day I gave you. Each day I gave you money. So the day before this, I gave you $2.5 million. The day before that, I gave you $1.25 million. The day before, I gave you half as much, correct? So if you chose the pennies option, you'd end up with a lot more money. Because on the last day, I'm giving you more money than I would have given you the other way. And the day before, I gave you half that. Holy shit, you'd end up with so much money. Some of you guys are like, I'm going to take the $5 million because maybe you'll die the next day, dude. And I got 1 penny from you. I understand. But anyways, you guys get the idea? If I double or triple something, it grows much quicker than we're used to. We don't think exponentially. And that's what this is. You all saw, hopefully you guys agree that this is exactly what's happening. Every time I multiply by 2, the power goes up by 1, correct? So this is what's called an exponential function. So the other way that I normally introduce this topic is to ask you a very strange sounding question. Where have we not shoved the variable yet? And you guys can't see what I'm doing because I forgot. So what I was just doing was circling these and saying, see how it's exponential? Okay. Good job, Jeff. We've put a variable with the power on it. We've put variables in the bottom of stuff. We put variables inside of radicals. We put variables all over the damn place. The one place we haven't put a variable yet is in the power itself. So what we just saw was an example of 2 to the x. Now again, some of you guys have done some of the math related to this class. Some of you guys have done exactly this class. But what does that look like if I graph it? So let's pretend like none of us know. If I'm given a function, I don't know what it looks like, what do I do? Very first thing I do is just explore what it looks like. Don't say put it in my graphic out there. What do we do as humans? Make a little table of values, right? A little table of values. So, whenever you're exploring a new function, because this semester we're going to learn some new functions, you don't want to just put in there 1, 2, 3. You want to put in some negatives. You want to put 0 in. You want to see what this function does with all the various kinds of numbers, right? So let's put in there -2, -1, 0, 1, 2. Those are my sort of go-to set of 5 numbers to plug in. 0, you got to see, can the function handle 0? Negative, can the function handle negatives? What happens when you... And then positive, of course, just, Okay. So complete the table, I'll wait.
Oh, wait.
So your function is 2 to the x. So just remind me, what's a negative power mean? Flip. Okay, good. Go for it. Go for it. drink. Come on, Mr. Drink. It's in here. All right, who's got the first entry? Yeah, 2 to the negative 2 is 1 over 2 squared, which is 1/4. So it's basically when you raise them to a negative power, pretend the negative isn't there. 2 squared is 4, and the negative just flips it, 1/4. What's 2 to the negative 1? That's crazy. 2 to the 0, anything to the 0 is 1. 2 to the first, 2 squared. Okay. So if I graph this thing, 2 to the negative 2 is 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. And 2 to the first power is 2. So a lot of you guys probably knew this already. Now let's investigate what's happening. So this side, it kind of makes sense. It's going to grow crazy. Has anyone ever watched like a horror movie or like where the creature's growing or a virus movie? We all lived through a virus movie. Great. Fantastic. Jeff, remind us about all of that. So they talk very often about the blob is growing exponentially, or the virus is expanding exponentially. So today it's covering this much, tomorrow this much, the next day the world. So exponential functions grow stupid fast. This thing just goes like crazy, and we know from the example we just saw, after 30 days it got over 500 million pennies. Holy shit, I didn't expect that. But what's it doing back here? What's it doing back there? Let's plug in something really stupid. What about 2 to the negative 100? Can anyone tell me anything about that? If you plug that in your calculator will definitely go, please stop. What would that be? Flip it, right? 1 over 2 to the 100.
Close to 0.
That's 1 over big number, yes? So when I get to 100, isn't it like stupid close to 0? Does it ever equal 0? 2 to the negative power. I'm going to do it like this. Would be 1 over 2 to the power. The only way a fraction can be 0 is if the top is 0. What is the top? Always 1. So therefore, what's happening back here? There must be a asymptote. A asymptote, Jeff, yes. There must be an asymptote right at the x-axis. This is the first time I think we're seeing an asymptote that's only one-sided. I'm trying to remember really quick. I don't think we saw a function yet where the asymptote only applies on one side. Pretty sure, yeah. Yep, every function we've seen so far, the asymptote is in both directions. This one, do you guys see what I mean by one-sided? Does this side give a shit about the asymptote? No. It's going, it's only the back side that cares. You guys with me? There are functions that exist that have asymptotes, a ceiling and a floor, for example. We'll see that later that semester. So don't worry about that yet. Okay. Let me stop for a minute. This is very trippy. So any number to a variable power will look like this. Yes? Okay. So if it was 3 to the x, it would have the same shape. Can anyone tell me what would be different, though? Yeah, 3 to the x is going to grow faster. It's also going to shrink faster. But every single one of them, the devil inside, no, every single one of them is going to have the same exact shape. Every single one of them is going to go through 0, 1, yes? Anything to the 0 power is 1. Okay, I like it. So not too bad, right? So here, you guys help me out. Take a second and graph this function. Every single one of us is put one inside. Now that we know the shape, you only need 3 points. And normally what I do is -1, 0, 1. Because now you know the shape. You don't need as many points, correct? realize I was doing that. That's funny. Whatever you're mumbling about, Jeff. All right. So when you plug a negative 1 in, what do you get? That's crazy. 0, of course, you get 1. And 1 you get, that's crazy. So it looks like negative 1, 1, 1, 2, 3, 4. So what if instead the function was, what, Jeff? I don't know. Come back here. Okay. Let's do red. 4 to the x plus 1 minus 1. What idea is this tapping into?
Shifting?
Shifting. What are the shifts?
1 down.
Yeah, that's last. 1 down.
1 to the left.
Not a stretch. There's no stretch. There's no multiplication going on. What's with the x? X plus 1, right? So it's going to move. Yeah, left 1. Yes? So if it's in with the x, it's the opposite of what it looks like. If it's outside, it's exactly what it looks like. So I don't care what function it is. They always act the same with these shifts. So once you learn transformations, once you learn shifts and so forth, I don't care what function it is. It's going to act the same way. So now I will take this point, for example, this one, and I'm going to move it left 1, down 1. This point I'm going to move it left 1, down 1. This point I'm going to move it left 1, down 1. Look, Jeff, I love you so much. You guys are sitting there just like, he'll figure it out. He'll figure it out. He's a math guy. He doesn't know direction. He doesn't know direction. He's having a bad day, okay? Go away. Just make my mistakes go away. I like this back, but it didn't happen, kids. That whole thing didn't happen. You're all sitting there like, I don't know, maybe this is some weird math thing. Okay, let's try this again. So, it'll go left 1, down 1. Is that better? Okay, everybody feels more comfortable now. Like, who's going to say something? This point's going to go left 1, down 1. This point's going to go left 1, down 1. Where's the asymptote going to be now? Normally it's at y equals 0. Now it's at y equals negative 1. So now my graph is going to look like this. Okay. You guys okay with that? Now? Just very quickly. This is really embarrassing, but too bad. I don't care. I've gotten a lot better. When I was a little kid, I had all the trouble. I always mixed up left and right. So my mom told me, okay, if it makes an L, that's left. So even when I'm older, sometimes somebody's giving me directions, and I have my hands like this in the steering wheel, turn left. Okay. All right. I got a lot of other shit in my head, so if you want to give me some grief, that's fine. It's okay. All right. So the nice thing is, any function we learn in the future, if I put an x plus 1 inside, it's going to move it back 1. If we put a minus 2 outside, it's going to move it down 2. It doesn't care what function it is. Okay. Okay, I like it. So last thing, I think, let me see. Just to kind of get us into the next thing, and then we're going to have an early day, because I want to. What about, all right, let's do this. So let me bring back 2 to the x very quickly, right? So I'm going to graph 2 to the x. So 1, give myself some more stuff. Okay, so 0 goes to 1, 1 goes to 2, negative 1 goes to 1/2, yes? So there is 2 to the x. Can you guys, so everybody draw that, I'll wait, go ahead and draw that graph. I like how some of you guys are like, let me just watch this guy. I'm not going to do anything until he figures out what he's doing. So we just saw how transformations don't care what the function is. Inverses also don't give a shit what the function is. As long as the function passes the what? Horizontal line test. So this is a function because it passes vertical. Does it pass the horizontal line test? Hell yeah. Every horizontal line only goes through once. Okay, I like it. So can you take a moment and on top of the graph you just made, can you draw the inverse? Make this f of x so that I can do f inverse of x. You guys remember how to do that? Yeah, what point is this? What point is this? 1, 2. So what's the inverse going to go through? 2, 1. Yes. Like. So that's 1, 2. The inverse is going to go through 2, 1. What's this point? 0, 1. So the inverse is going to go through 1, 0. And then what's this point? Look, I was about to do this. Oh shit. This is the point, -1, 1/2. So what does the inverse function go through? 1/2, -1. Now, real quick. Inverses, switch x and y. That's the idea we applied. Where is the asymptote of the original function? It follows the what axis? The original function follows the x-axis, correct? So, of course, the inverse function is going to have an asymptote on the y-axis, because all the inverse does, very, very single-mindedly, is switch all the x and y shit. So now, for the new function, there's going to be an asymptote here, so it's going to look like this. That's a really horrible picture, but you guys get the idea. So as quickly as this thing grows very slowly eventually. It's going to grow very slowly. But it's always growing. This function, we don't even have a name for it yet. But that function is one of the slowest growing functions there is. Does anyone know what that function is?
Decay?
No, because it's growing.
Oh, yeah.
We still have to talk about decay, but that's okay if you don't. It's fine. It's actually called, let's see how you guys react. That is the graph of a logarithm.
Yeah.
Do y'all agree that exponential functions are pretty straightforward? If you have to graph it and you plug stuff in, it's just raising 2 to a power. What do you do? Who cares? Most of the time, students are very definitely afraid of logarithms. If you've used them before or whatever. They are also very simple. But it's just a poor choice of symbol. What's the inverse of x cubed? What's the inverse of x cubed? What's the opposite of cubing something? Cube rooting. Now, that's not the greatest symbol ever, but that symbol is actually not bad. It's a good symbol. It's like I can see it's doing something to this. If I have a function 2 to the x, the name we give to the inverse function is this. And this is part of the reason why students hate it. It's log base 2 of x. That's just a really bad choice. That's just a really bad, let me put it over here. F inverse of x equals log base 2 of x. That is just a bad choice of symbol. Later this semester, we're going to learn about sine, cosine, all that kind of business. It's another symbol where the freaking thing is like a word. And those are weird. But we could have chosen a symbol like the cube root symbol, but just different. But we, crazy-ass math people, we like Latin. So let's use logarithmus, which means the ratio of the numbers, and you know. What? No. Too bad for us. Okay. So before I go, forget. So we gotta explore logarithms. Since we had a graph of this sucker, we could graph the inverse. We graphed the inverse before we even knew what its name was. Correct? Okay. So last little thing for today, since this kind of came up a second ago. Do you all agree that this would represent growth of a population? If I start with a couple bunny rabbits in a room and I give them some food, it's going to explode. The population in that room is going to explode after a little bit. Yes, I know. I'm picking on rabbits. They're kind of known to do that kind of thing. You guys all with me?
Bacteria too.
If I look at the reflection of an exponential, can somebody tell me if this is 2 to the x? Can somebody tell me what I would do to make it look like this? What would that function be? Negative 2 to the x would just flip it this way. 2 to the negative x would flip it that way. This represents decay. What happened in Chernobyl? Anybody know Chernobyl? Anybody know that word, that name, the city? What happened there?
It had a steam explosion that breached the reactor.
There we go. Bad things happened. Very radioactive. Yes? There's all you got a was it HBO series or whatever? Yeah, horrific. Holy shit. And it was true. It was horrible. But over time, the radioactivity is going to go down, but it's going to go down very slowly. I think it's like a half-life of 5,700 years or whatever, the specific radioactivity. Which means after 5,700 years, half the radiation is still there. That's what that means. So over time, it's going to decay, is what it's called. So this is exponential growth, and this is exponential decay. This could model population growth. This could model, like I just said, radioactive decay. Right? You guys kind of with me? A little bit? Not really? So theoretically, will the radiation ever go fully away? Will it ever hit 0? No, because it's a freaking asymptote there. Too bad, huh? So we're always bathing in radiation, especially if you go up in a plane. Okay. On that note, that's enough. Oh, sorry, go ahead.
So would a half-life be 1/2?
Oh yeah, you got it. Okay. So Half-Life is not just a video game, but it's like this literally would be like if I wait one time period, like it'll have half of what it had before. Does that make sense?
Yeah.
So this is directly related to the idea of half-life.
So 2 negative x is half-life.
So like 2 to the 0 is 1, 2 to the negative 1 is 1/2. It's literally cut in half. So half-life in general, like I just said, half-life is how long will it take for it to have half of that left, half of that radioactivity left. So the half-life of some things is like on the order of thousands of years. For other things, it's on the order of milliseconds, right? Unfortunately, most radiation that will hurt us is a lot. It's very many years, yes. Okay, on that note, that's enough. So, have a good weekend. I will see you guys next week. Talk more about this crazy stuff. Everybody got their test back, right? Oh. Oh, yeah. There's a lot of information. Everybody else good?